Okay, welcome to AIM tutorial, and today we will learn about machine learning algorithms. Gone are the days when we were talking about artificial intelligence. Now we are at era when we are going to discuss or communicate with the help of big data, and we are handling the data science as well. So in order to learn the data science algorithm or the deep learning algorithm, first and foremost we must have idea about machine learning algorithm. Okay, so before starting we must have the different kinds of machine learning algorithm. First one is supervised learning, second one is unsupervised learning, third one is semi-supervised learning, and then we will discuss about reinforcement learning. Okay, so what is the supervised learning? As it is shown inside the figure, that we are having raw data and it is having different features and different inputs as well. So we will give these features into the data and algorithm, and then we will process the data. Okay, the entire pixels, the pixels are having values red, green, blue, or any other color format you can have, and it will just analyze the pixel values every time. So then it will go to the next model train, and then it will going to identify or classify that it is this object is tomato. Okay, so this is the kind of supervised learning. We have already trained data and it is going to identify or classify the data. Okay, so what are the different types of supervised learning? It is regression, second one is random forest, then SVM classification, then we are going to discuss this KNN, then we are going to focus on logistic regression, we are going to emphasize on naive Bayes theorem, decision trees, and so on. Then let's have a look on the regression part. Actually it's the data which is scattered on the X and Y plot. Okay, and it is having different sectors and different values every time. So regression is used to understand the relationship between dependent and independent variables. It's commonly used to make projections such as for sales revenue for a given business and so on. And you must have idea what kind of features you are having and what kind of data you are having in order to train and in order to predict the certain value. Okay, so this data is having certain pattern in the linear fashion. We are going to draw a line with the help of y is equal to mx plus c, which we have studied in the class 12th. Okay, then the second algorithm is SVM, support vector machine. This SVM model is basically a representation of different classes. Suppose we are having class 1 here, then we are having class 2 here, then in a hyperplane in multi-dimensional space. The hyperplane will be generated in an iterative manner by SVM so that the error can be minimized. We are going to define the most interior, means most nearest data, and what is the difference between these two. Actually it is the advanced version, or means advanced format of the regression, you can say. So it is going to calculate the gap between these two data, class 1 and class 2. Those are having nearest model, and then it is going to working towards our goal. Then the next algorithm is supervised learning type KNN. K nearest neighbor algorithm stores all the available data and classify a new data point. Suppose we are having input value of any random cat and any random animal, and it is going to classify whether it is dog or cat. So it is going to identify it, is going to predict anyhow that what kind of data you are going to train in your model, and with the nearest model, with the nearest kind of pixels of image, it is going to train the model and going to predict as of now. And one by one we will learn about the coding part of these algorithms as well, because Python is very much familiar in order to run these algorithms. And then supervised learning type, then we are having logistic regression. It is the advanced version of linear regression. We are having in the linear part, linear fashion the data. But what about the data is not in the linear format? Then logistic regression is a supervised learning classification algorithm used to predict the probability of a target variable. The nature of a target or dependent variable is dichotomous, which means there would be only two possible classes. So you can have the threshold value every time. Then we are on the basis of probability, we are going to define the prehistory of the data, and on the basis of prehistory of the data, the probability whether it is true or false, whether it is different kind of class 1 or class 2, it is going to define the probability. So it is the probabilistic classifier, which means it predicts on the basis of probability of an object. Okay. Then what is decision tree? So similar to decision tree, similar to binary tree, we are having left hand side and right hand side tree, and every time we are going to classify in between 0 and 1, or you can say true or false. Oh, suppose I take an example to purchase an object or buy any item from Amazon or Flipkart. So whether the customer of the certain background or certain history or browser history will purchase this item or not. So Amazon must keep sale on this targeted customer, and they must have the idea whether they are going to sell the particular item or not. So it is called decision tree because similar to a tree, it starts with a root node which expands on further branches and constructs a tree like structure. Okay. Then we are having unsupervised learning. This is the second type of learning. So as of now we were talking about supervised learning. Now we are having unsupervised learning without the labeled data. It is not having the defined features, it is not having the input, it is purely input raw data. It's a kind of machine learning in which models are trained using unlabeled data set and are allowed to act on that data without any supervision. Then what are the different algorithms? The algorithms are a priori, FP growth, RM, HMM, GMM, and so many features are there in order to explain the unsupervised learning. So keeping in mind different kinds of unsupervised learning, first and foremost we are going to emphasize on k-means. What is k-means? Identifies it k number of centroid and then allocates every data point to the nearest cluster. So initially we are not having the centroid. First and foremost we need to create a centroid for each class. Okay. Then we are going to define the neighbor of each class and what is the what is the sector of that class, what is the area of that class, what are the different features of that class. In order to associate with the certain cluster, we will going to decide the class 1, class 2, class 3 and so on. So this is the basic idea of k-means. Then we are going to define a priori algorithm in order to associate the certain bunch of objects, and we are going to define the certain parameters and certain algorithm behind. You may also like, means suppose you go to buy a product from any means any shop or any shopping mall, then you are going to purchase a laptop. So obviously you will purchase a webcam. The customer will purchase a keyboard, mouse and so on. So this on the basis of frequent item sets to generate association rules. Then we are going to define the sale, purchase and so on. Then we will move to hierarchical clustering. It is used to group together the unlabeled data because the data is not having the defined characteristics. It is having cluster 1 and cluster 2. It is having domain 1 and domain 2. Then on the basis of these features we are going to define anyhow with the similar characteristics. Then most importantly, autoencoders. Now deep learning and the machine learning and the different data science are mostly uses this autoencoders to run their data, to define their customers and so on. So in autoencoders, we leverage neural network. Actually, deep learning is the part of advanced part of subset of neural network, you can say, and the autoencoder is a type of deep learning, you can say, and this is going to define the input and the bottleneck or output, and then complete the architecture and define the output, or you can say predict the output on the basis of certain encoding and decoding process. Then principal component analysis. It is used to multi-dimensionality reduction in machine learning. It is a statistical process that converts the observations of correlated features into a set of linearly uncorrelated. So once you are supposed to define the price of a wine, and different kind of wines you are having in your depot, and then you are going to take advice from different means tester. They test the wine one and they just give the rank from 1 to 10, in between 1 to 10. Then you just taste the second wine to the first tester, then it gives the second opinion, then it gives the similarly you give the second tester, you choose the second judge or the person, then it is going to test the second wine, third wine, and so on, and according to their judgmental analysis, they assign the parameter values. On the basis of these parameter values, we are going to assign these principal components. This is the reason it is called principal components, and eventually we are going to predict the price or cost of the wine. Then we are having singular value decomposition. So gone are the days we were talking about the labeled data or artificial intelligence. Now we are working on the unlabeled data. So where we are having the different pixel values of dog, cat, cow, lion, tiger, and so on. Then each single decomposition analysis is going to discrete in the different factor. Then we are going to define in singular values and then multiply the subject vectors. So eventually it is going to calculate. Actually it's a more purely mathematical portion, and purely skit-learn and SciPy algorithm, SciPy libraries are used in order to run such kind of unsupervised learning algorithm. So singular value decomposition is purely mathematical algorithm, and we are going to define in this way. Then frequency pattern growth, which is having tree based architecture, and association rule is going to create in order to sample get together, means first one, second one, output, third output, and so on. Then we are having hidden Markov model, HMM. Most of the companies, IT companies, non-IT company, medical fields, and different sectors, healthcare sectors, DICOM images, they are going to run these means they run this hidden Markov model they are using for in order to analyze their data. And they are having snow kind of, means what is the probability there, what is the probability of rain there, what is the probability of sunshine. On the basis of this probability value, they are going to predict the weather as well. So it is very tedious task to work on labeled data and unlabeled data. You cannot say that the data which is acquired is purely labeled or unlabeled. So in practical we are having group of data, means fraction of data is having sampled and fraction of data is having unlabeled. Then we are going to code and last new sample and get together in order to train the entire data. Then we feed into the certain algorithm, and then we go to the product of trained algorithm. So this is the raw data, and we are going to define into the semi-supervised learning. So in the key part, the most essential part is it is having data in the format of labeled and unlabeled both. Okay. Then finally the fourth part is reinforcement learning. What is the reinforcement learning? The most emphasis part is we are going to reward or the penalty. penalize the data. So what kind of action you are taking with the data, whether it is purely defined or means truly predicted, or it is going to false prediction. So we are going to, according to the same format, we are going to give the reward or the penalty. So if you are having so many large scale of raw data, then one by one the algorithms feed into the algorithm. Once it is having less error, then it is going to reward the algorithm. Then if it is having more error, then it is going to reward, means going to penalize the data. So according to base of the environment and an agent, we are going to train the entire data set. So this is the method of reinforcement learning. So moving towards, we are having free resources page, sachinsax.blogspot.com. You will find all these data set and all these algorithm coding on my YouTube channel and on my blog as well, and you can have the data and so on, and you can have the free code, free learning lessons and so on. Thank you. Now let's go get back to code. Thank you.